little bit of a different type of recording today. Okay, I'm going to review a few things before I do the demonstration today that I want to show you. Okay, and this is kind of the culmination of the things we've been talking about all week. So first of all, we've been talking about thermodynamics, which is the movement of what type of energy? Yeah. Kinetic. And kinetic energy, and we can also call this what other type of energy? Starts with therm and ends with mole. Yeah. Thermal energy. Sure. Thermodynamics. Heat energy. Basically, we're looking at heat. What is it? Well, it's really, as Parker said, kinetic energy. And it's the kinetic energy of the what in a substance? It's not this. It's not up here yet. What is it? What has energy in a substance? Empty space? Caleb? Atoms, right? Atoms. So you see we have some atoms up here on the board here. All right. Temperature is this key idea. Temperature, as was defined several days ago, is the measure of the average kinetic energy in a substance or object. It's the measure of the average. That's the key idea. We add up all the energies of the atoms, and we take the average, and that is temperature. However, the way that thermometers are designed, okay, the way thermometers are designed is that they kind of do this naturally. And so what happens is we need to kind of understand how a thermometer works in order to be able to kind of understand this idea of temperature. So it used to be that thermometers had mercury in them. Why don't we use mercury anymore? Yeah, Parker?
They used to break sometimes.
They would break, and it's harmful. It's a poison, okay? And so we don't want that. It was really, really effective. Really, really effective. Savannah?
Couldn't if it got too hot, it could actually explode?
If they got too hot, they wouldn't explode. They would just, kind of like in the cartoons when you see it go, pow. You know, they never did that. But it would cause them to malfunction and then get ruined.
Is that a mercury thermometer in Michelle's cage?
No, it's not.
Oh, I thought
It's
you
an
said.
alcohol thermometer. Alcohol is what you'll see. If you see red inside a thermometer, it's alcohol. If you were to see silver inside a thermometer, that would be mercury, or Hg off the periodic table. Yeah, Caleb?
How could you even see it? I mean, it's hard enough to see the red.
Well, when you hold it up, you'd be able to tell. You could see the red. You look at the bottom mostly. Okay? The bottom little bulb on a thermometer.
Oh.
Okay? So, why is it that when it gets warmer, it rises? The alcohol rises. Yeah.
Because, like the energy in it, expands it.
Okay, the energy expands it. So let's even break that down a bit further. You're right. Okay? You're correct. Let's go even deeper with it. Yeah, Miss Lalonde.
It has, nowhere else to go but up.
Okay, it has nowhere else to go put up. That's true. We don't have a bunch of little valves coming off it. We have one direction up. So it does expand. Okay? Oh, no. One direction. Yes.
Yeah.
All right, and so we have this one direction it can go, and it's up. I want you to kind of visualize this. Could I please have Parker, Grace, Bo, Connor, Noah, and Emma come on up? It is on. Yeah. Okay, I want you all to stand shoulder to shoulder. Shoulder to shoulder. We're going to be in a big group here. Big group, big group, big group. Okay. Big group. All right, very good. Parker's in the middle. Okay, stop. This is a cold thermometer. They're all wiggling a little. Okay. But then I pour on some heat, and all of a sudden, what do they start doing? Oh, yeah, this is exactly it. And they're starting, it's like the atomic mosh pit, okay? And they're going to start going crazy. And they get in there, and they start pushing out of the way. All right, stop. And you may sit down. That's exactly what happens in a thermometer. You just saw the human thermometer, ladies and gentlemen. The human thermometer. The atoms gain energy. They start throwing elbows. They start kicking and kneeing and biting. Okay? And they start pushing, and they need more space. And so, what is the only, ladies and gentlemen, what is the only direction they can go?
One direction.
One direction, up. And so they do. And the more energy, the more they need to expand. And the less energy, the less they need to expand. And so that's how a thermometer fluctuates up and down. This is all based on this idea of the atomic mosh pit.
How do you call it that?
Okay? Or, AKA, thermal expansion. That's what we're dealing with here. We're dealing with the atomic mosh pit, thermal expansion. So that is how a thermometer works.
Why?
So here we go. We're going to put a little bit more.
How much alcohol we put in it?
Slice out alcohol.
The whole enchilada.
Because there's a ball behind it and it's reflecting off the
No,
color.
it isn't.
Like,
That's
she's
alcohol.
Okay.
Orange, see?
Are you gonna like burn that ball?
Put the whole.
Oh, he's gonna.
enchilada.
I see what he's trying
It's
to do.
gonna catch fire and it's gonna
Okay.
go through the seed.
Now, safety precaution, we should probably remove all open containers of flammable liquids from the
Well,
vicinity.
so the thing that the bird's drinking is water. It's not like alcohol.
Yeah.
Right.
So
Okay.
So
We remove all flammable sources of flame from the, or all flammable containers.
Will this be loud?
Gas in the
Okay.
fire.
Listen, hey. Ladies and gentlemen. Next. Will someone please grab me that bin back there off from the... Because of the nature of this demonstration, it is always good to have a second layer of protection in front of it, just in case.
Oh, like in front
So
of us?
I just put this container up right here, just so that,
What about for you?
well, I'll be fine,
Well,
okay?
I don't
Okay.
know. Do you need to get the fire?
Ladies and gentlemen, hey, need to mix it all up. Okay, someone turn the lights off, please.
I will. Wow, Mr. B. Do you need a fire blanket? Oh, can we close those blinds?
No,
there is a
no,
fire
no, no.
blanket. It's over there. Okay.
Fire blanket, all the safety stuff is in the back there.
there. On the top. Connor, fire blanket. Connor, if someone catches on fire, you gotta get really tall.
Okay.
I will too. I will too. I got it.
Now, same idea behind the cannon. When we light it, it should produce a considerable amount
A fire.
Must use this even though
flame. It's been well mixed. So let's go ahead and see what happens. I cannot guarantee this will work. First of all, I've done it once already today. And because I've already done it once, there's some residual water left over in there which will hinder this from performing. So here we go. This should, if it works, produce a really good example of thermal expansion. Okay?
Oh, I see.
Yep, it definitely did.
Awesome.
Okay?
Left a mark.
It did leave a mark. What did you just see?
I don't know. Oh.
Yeah.
The atoms, since there's like alcohol atoms, since they're really flammable, you hit them with fire, so then they caught on fire, and then the atoms didn't explode. They didn't have anywhere else to go, so they went up, and then they pushed the bally thing up there and hit the light, and the light turned orange.
We should have seen
Okay.
It smells disgusting.
Huh?
You know, you need to do it. You need to do it in the hallway and see how
All right.
Anybody-
Well, I will tell you this. Okay, before I show you the video. The bottle, okay, underwent a chemical reaction. Combustion reaction is what we call it, because there was a lot of heat and light produced. This bottle is very warm right now. And so, because there was so much heat produced, so much energy produced, it caused the atoms to start to vibrate considerably faster than they were. And as a result, they collided with the basketball,
Basketball
which
right
is,
there. At least
which
it
is
didn't land in
here.
the bird's water.
and the basketball was then projected so that the fumes, or what we call the exhaust fumes, could escape.